The objective for this lesson is to be able to use a trig graph and come up with a trig equation from that. The general look of a trig equation is y equals c plus a times, and we'll use sine at the beginning here, sine of b times x minus d, where c is the value that's been vertically translated, a is the amplitude of the graph, b is how the period has been changed. Usually you take the standard period and divide by b and you get the new period. And then d is how much it's been horizontally translated for your starting point on the graph. So this first one here, if you look at it, it looks like a sine graph. So that's first to use the shape in order to come up with which trig function you think it is. This looks like it's a sine graph. So I'm going to put y equals, and I'm going to list the sine here as my starting point. Now I'll talk in a minute about how it could be a cosine as well. But for now, sine, and then notice that the number, it doesn't have the midline. Midline is still the x-axis. So since the midline's the x-axis, we haven't translated up or down, so there's no c in front, but the amplitude has been changed up to 10. So we're going to make that 10 times sine. So when you look at that, we've got let's change that a little bit. So we're going to put that equals 10 times sine. Now, on the inside, the period has been changed from 2 pi to just pi. Notice that when we graph this here, it ends at pi for one period. Well, because of that, that means that the way to calculate it is to say that 2 pi over b is going to just equal pi. Now we can figure that out, that's going to be b is equal to 2. So if you don't catch that right away, you could multiply by b on both sides and get 2 pi equal to pi times b, and then divide by pi and you get b equal to 2. So our equation would be 10 sine of 2x, because there's not been any horizontal translation for that. So there's an equation that matches that graph. Now a second equation might be is if you look at this and say this could be interpreted to be a cosine graph if we start it here and look at one period going from there to there. Now we need to know where that starts, and notice that's a fourth of the way to pi, so this is pi over 4. And then it ends just a pi over 4 past pi. But that tells us that when we look at this graph, if we think of it as a cosine, it still has the same amplitude, so 10 times cosine, and we still have 2 in front because we've changed the period, but we've translated it horizontally, pi over 4. And remember, inside the parentheses, you always go in the opposite direction. So since we moved it to the right pi over 4, we make it minus pi over 4. This graph, the graph of 10 cosine 2 times the quantity x minus pi over 4, is the exact same graph as y equals 10 times sine of 2x. So notice we can write them in different ways. It's just usually easier if there's not a type of horizontal translation to change it. All right, let's look at the next one. The next one looks like it's going to be a cosine because it starts at the top of the amplitude. So one period here, they start it down here when they say the period's equal to 4, but if I were to start it here and finish it there, that would give me also a period of 4. So I can write this out as y equals, now we've translated it up 3 units. Notice that that's gone up, the midline has gone from the x-axis up to 3. So it's going to be 3 plus, and now the amplitude has been changed. Notice it says the amplitude is 2 because it's 2 units above that new midline. So we're going to have 2 times cosine. Now we've got to go to the inside part. Since the period has been changed to 4, Now we're going to assume this is in radians because it doesn't give any degrees on it. So if you look at that 1, 2, 3, 4, etc. on it, there's no degrees on it. So then your assumption is that it's in radians. So we're going to say 2 pi over b is equal to 4, because that's what our period has changed to, multiply by b on both sides. You get 2 pi equals 4b, so b is going to equal 2 pi over 4, which reduces down to pi over 2. So I'm going to put my b here, which is on the inside, as pi over 2 times x, because it starts at right on the y-axis, so there's been no horizontal translation for it. So this equation, looking at the shape and how it's been translated and how the periods changed and the amplitudes changed, here's an equation for that graph. Let's do a tangent one next. So notice that I say this is tangent because it has the shape of starting down and going up. Now we could make it a cotangent with a negative in front of it because that would flip it over. But this shape tells us tangent. So I'm going to start with y equals, and then I'm going to use tangent. Now it has not been vertically shifted. The x-axis is still the midline of my graph. So because of that, I'm going to not have a number being added in front. Now the next part is a little more difficult. We don't know if there is some number that would have changed the amplitude of a sine or cosine in front. So when we do tangent or cotangent, we just assume that there's been no number multiplied in front. We don't have the ability at this point to calculate if there's a coefficient in front of the tangent. So when you do tangent or cotangent, just look for the shape. Don't worry about a coefficient in front of them, implying that there would be an amplitude change, which there is no amplitude for tangent. Now, we do have to deal with the period change here. So notice that the period here from -4 to 4 is 8 units. So what we're going to have is that our period 8 is going to be equal to pi, because we don't have any number or no degree markings with it, so we're going to assume that the standard period will be in radians. Remember, the standard period for tangent is pi instead of 2 pi, and we're going to divide by b to get the 8. I'll multiply by b on both sides. 8b equals pi, b equals pi over 8. So I'm going to have tangent of pi over 8 x for my equation. There's been no vertical shift, no horizontal shift, so we just have to deal with the period change here. All right, and lastly here, we're going to look at this one that looks like it's either a secant or a cosecant, and we have to decide which one we want to use. We could use either. But what I want to do is I'm going to sketch out what could be the sine or cosine graph by looking at the asymptotes. And notice where there's an asymptote, the sine or cosine would be a 0 value on the midline. So I'm going to mark those points where it crossed the midline. And then the graph would, to deal reciprocally, will go and meet the graph at its minimums and the maximums. So this graph looks like an upside down sine. So when we're doing this, we're going to think of it as a reciprocal of sine, and with a negative in front. So no horizontal shift on this because it starts right on the axis, but we do have a vertical shift. So we're going to put y equals, let me do the sine graph first, and then we'll throw in the in this case, cosecant, because it's a reciprocal. So what I drew in purple here, I'm going to make this equal to the vertical shift of 1 unit. And then notice that it's going down first. So I'm going to subtract the sine. There's no amplitude change because it goes up 1 unit above the midline and 1 unit below. Now, I've not shifted it side to side anywhere either, but I do have to look at what is the period on this, and notice that I have two periods drawn here. So one period is pi, so pi will equal the 2 pi over b for the sine graph multiplied by b, so b times pi equals 2 pi, divide by pi, and you get b equal to 2. So I'm going to have 1 minus sine of 2x, since I have not shifted it side to side. So that would give me that graph that I see in purple. So if I want to change it to the original graph, that would be the reciprocal. So that would be cosecant of 2x. So my recommendation for doing the secant or cosecant, draw out what the sine or cosine graph is, use that to guide you, and then just replace it with the reciprocal to get your original. So this graph is 1 minus cosecant of 2x. So when doing these graphs, you need to make sure you use, first of all, the shape to decide, is it going to be a sine, cosine, tangent, cotangent, secant, or cosecant? Then look at the period and use your formula, 2 pi over b for sine, cosine, secant, and cosecant, or pi over b. Notice when we did a tangent, it was just pi over b here, for equal to the period for tangent and cotangent. Find out what your b is, and then you can look at whatever kind of the location being a translation. Is it translated up or down or side to side? And then use all of that information to finalize what your equation is using the graph to come up with it.